The physical parameters that are affecting the key rate in the QBER, in this case, are listed on this page. And in our particular setup, these are the key parameters that matter the most. At the top is the source visibility. This is how much of the entanglement that we can see in the source, and basically is the signal to noise ratio of entanglement in our entanglement source. The source brightness is the number of photon pairs that are emitted per second. Transmission efficiency captures how much loss there is during transmission. Detection efficiency captures how much loss there is during detection. Dead time and dead time efficiency capture how much loss is associated with the detector not being able to register new events. This is something that happens when detectors register a photon. They become inactive for a certain amount of time as they reset to get ready to collect the next photon. Then finally, dark counts are photon detection events that are not attributed to our entanglement source and are coming from other sources such as thermal noise or external background light in the experiment. Now, we actually went to our BrightNet setup and took all of our hardware components that we were using for quantum key distribution and calculated the visibility and efficiency of all of these components to capture physical parameters that describe and characterize the hardware that we have in the lab. You can also get many of these values from spec sheets that you might find online for the hardware that you might purchase, and that would be a good starting point to begin with if you don't have hardware to characterize. However, since there is some variability in the actual hardware performance given the spec sheet, you would always do better with your modeling and parameters by characterizing your actual hardware after you get it. But starting with the technical specs in the spec sheet is the starting point for designs.